Okay, so welcome to the first Unit 3 video over the atomic theory. You should be taking down these notes as well as questions and then complete the summary when you're done. Okay, so there's one question we're going to be answering throughout this whole video. It's what scientists contributed to the atomic theory. So I'm going to go over 5 scientists, and for each one I want you to write down their name and the date when they made their discovery, what their research was it some sort of experiment, what is their theory of atomic structure, if you want to draw pictures you can, and then what are the limitations of their models. Okay, so our first scientist is Dalton. This is an English teacher actually, and in 1808 he just made simple observations of chemical reactions. So for example, he noticed that if you combined one oxygen atom and 2 hydrogen atoms, you would get 1 water molecule that's composed of those individual atoms. So he had 5 what are called postulates, basically their ideas. Do not copy all of those down because you don't need them. But those 5 postulates are: all elements are composed of atoms, okay, and those atoms are identical. In particular, they weigh the same amount. The atoms of one kind of atom are different from atoms from another element. And then atoms are indestructible, and they retain their identity no matter what type of reaction they go through. And then the compounds form in whole number ratios. So for example, what we just looked at up here, okay? So there are some limitations of this theory, and the first one you're going to learn in the very next video. Not all atoms have the same mass. We're going to learn that there are things called isotopes, and those are basically atoms of the same element, but they weigh differently based on the number of neutrons they have. Another limitation is that atoms are not indestructible. We know that you can split an atom. We can do this in what's called nuclear reactions or nuclear chemistry. And so those are just a couple of limitations, but the general idea was good. Okay, so the next scientist on the timeline is Thompson. This was an English physicist, I believe, and his experiment was the cathode ray tube. Basically, he just shot cathode rays in tubes, very straightforward. He did this in 1897, and basically what he did was that he discovered the electron. That's what he gets credit for. And his model is known as the plum pudding model. So what he did is he noticed that there was a deflection because of these negatively charged electrons. And so what he said was that the positive was evenly distributed and then the negative electrons were within that. Kind of looks like a chocolate chip cookie. So the limitations of this are that where's the nucleus? We know that there is a nucleus. We know that the positive is just not some cookie dough evenly distributed. So that was a big limitation of his model. Okay, so the next scientist is Rutherford in 1911. He did what's called the gold foil experiment. He had a sheet of foil here, and he shot particles at it. And when he did that, he noticed that some of them came back onto the screen, but most of them just went straight through. So what he realizes is that these few that were coming back are due to a positive and very dense nucleus in the center of the atom, and the majority of the atom is just empty space. So if you look down here, this is an image of what his model was. So those few that hit the nucleus bounced back, but most of them just went straight through. And so his model doesn't really include anything about what the electrons are doing. In fact, based on his model, the atom would just collapse, because we know that positives and negatives like to go towards one another. So based on his model, he didn't have anything to do with the electrons. He didn't explain anything. So based on his model, everyone just assumed, well, that meant that atoms would just collapse because the electrons would go straight to the nucleus. So there is a huge limitation for his model, but he gets credited for discovering the nucleus. Okay, so the next scientist was Bohr, and in 1913, he made his discovery based on what's called hydrogen's emission spectrum. So this is where math started getting into atomic theory, and what he did was he realized that electrons have a particular amount of energy. And based on that amount of energy they have, they are in what are called fixed orbits around the nucleus. And so how did he discover that? He noticed that whenever he would energize a hydrogen atom, that he just assumed, well, it's going to hop up an energy level, and then when it comes right back down, it's going to have to give off that energy. And he was right, because when this happened, that would give off colors of light. Based on how much energy that electron has, it would give off a particular color. And so he noticed that electrons, based on their energy, are in orbits, or energy levels is what it's referring to here. And so y'all are familiar with a Bohr model. You're filling in the electrons in those fixed orbits. The limitations of this only worked for hydrogen. And so when any other scientist tried to study emission spectrum of any other element to see if this was working, it didn't apply. And also, he did not explain the behavior of an atom. And so, yes, there's electrons, they're in some sort of region, but how does this explain why atoms behave the way they do? So that'll be the focus of the next scientist. So in the past, you guys have usually stopped with Bohr's model, but in reality, the atomic structure has changed quite a bit due to a guy named Schrödinger. Schrödinger in 1926 came up with a very complicated mathematical equation that basically allowed us to predict where electrons were. This is known as the quantum theory, and it's all probability based. And how he did this is because he predicted that electrons behave as waves, and they occupy spaces that are called orbitals. He got his name orbital from Bohr's model, but in reality, electrons aren't just circling around the nucleus. He proposed a theory, and it looks like this. So here's the nucleus, and based on the mathematical equation, he realized that there was a particular region where there was a high probability of where that electron would be. And so the darker the space, the more probable the location of the electron. So obviously that is a big limitation. It's all probability based. We still do not know 100% sure exactly where the electrons are. We just have a probability base, like it's 90% here most of the time. Maybe in the future this will change, but this model has actually been verified, and I'm going to show you how it's been verified in class tomorrow. Okay, so just to summarize, we talked about Dalton and his 5 postulates, and then Thompson came along and discovered the electrons. Something that he failed to recognize, though, was that there was a nucleus, which leads us right into Rutherford's model. He noticed that there was a nucleus, and it was positively charged, but he did not do very well when it came to the electrons. According to his model, the atom would just collapse. So that leads us right into Bohr's model. Bohr talked about orbits that the electrons were in, which made up for the collapsing problem of Rutherford's model, but it does not include what we know about electrons today, which is that they behave like waves. So that leads us right into Schrödinger's quantum mechanic model, and that they are in orbitals, or also called electron clouds. But this is not very realistic. It's only probability based. And so make sure that you have all of those scientists down as well as the dates, and we'll talk more about this in class tomorrow.